Okay guys, let's keep going. Part 2 of the EOC review packet, number 29. Kelly makes two different size ceramic tiles in the shape of right isosceles triangles. Okay, so the diagram shows the leg lengths of the small tile. Kelly makes a larger tile by increasing the length of each leg in the small tile by X inches. Which expression represents the length in inches of the hypotenuse of the large tile? Okay, so they tell me it's isosceles. I know that because these two legs are both 3 inches long. Okay, so that's an isosceles right triangle. And by the way, this takes us into our special right triangles. If you remember, if we have an isosceles right triangle, the only way that can happen is if these two angles are both 45 degrees. Okay, so I'm going to come down here and just draw a small triangle just to refresh your memory on the specials. 45, 45, 90 right triangle. If you remember, whatever these legs are, x and x, because they're the same length, the hypotenuse is just x times the square root of 2. So if the leg is 6, the hypotenuse is 6 root 2. Okay, so that's essentially what we have here. So like my x would be 3. So if this is 3 and this is 3, then this length would be 3 root 2. However, they're saying that Kelly is making a larger tile by increasing the length of each leg by x inches. Okay, so I'm going to come over here and draw Kelly's tile. It's a little bit longer. Okay, so oops, I can see that. So instead of each of these being 3 inches, she's adding x inches. So that's going to be x plus 3 inches. This is also going to be x plus 3 inches. I'm increasing by x on each side. So instead of this being 3 inches and this being 3 root 2 inches, now the hypotenuse is going to be the leg, whatever the leg is, x plus 3 times the square root of 2 inches. I'm just tacking on a square root of 2 on the end. So my final answer is x plus 3 times the square root of 2. Okay, guys, if you can't remember that, okay, if you cannot remember that, let me show you how to check this on your calculator. Okay, this is going to be a little bit tedious, but you can do it. If you're like, man, I just don't know, I can't remember what I do with the hypotenuse, I can't remember. I'm also going to refresh you guys' memories on the 30, 60, 90 triangle, right triangle. And this is difficult because you've got a lot of stuff to remember. The angle across, the length across from the 30 is going to be your short leg, so that's going to be x. The hypotenuse is going to be 2x. And the long leg opposite the 60-degree angle is going to be x times the square root of 3, if you guys remember that. So I know a lot of students sometimes get confused between those. Oh man, I can't remember. Is the 45, is this 2x? Is it x root 3? Is it, you know, whatever. So one way you can remember, if you remember the way I taught you, is you've got 3 different things over here. Okay, you've got a 30, a 60, and a 90. You've got 3 different angles. Okay, so I've got 3 different numbers over here. With the 45, you only have 2 different things here. I've got an x and an x root 2. So if I only have 2 different angles, the 45 and 45, that's going to be the x root 2. I only have 2 different angles. Over here, I've got the 30, 60, 90, 3 different angles. This is the one that has the square root 3 in it. Okay, just a quick little way to remember that. So if your brain drops out on the test, you're like, man, I can't remember. What is this new hypotenuse going to be? Is it 2 times that, square root of 3? Here's how you can check it. I know that each of these legs is going to be x plus 3, okay? So I can take each of these answers and plug it in for my hypotenuse and see if a squared plus b squared equals c squared, okay? So this is the way it would look. Make sure y'all can see this on the calculator. I'm going to do a squared plus b squared, okay? X plus 3 squared plus b squared, another x plus 3 squared, and I'm going to get a number. I do not care what that number is. That is a squared plus b squared. That's some number. I just got to make sure that my hypotenuse, my c squared, equals that same thing. Okay. So when I type in x plus 3 root 2 squared, okay, and I'm going to do that whole thing. So here, actually, I need a couple set of parentheses. Okay. So I'm going to have x plus 3, close that parentheses, times the square root of 2, and then I'm going to close that. Whoops. I need to get outside the house. So remember to go outside the house. Close that parentheses and square that. Oh look, guess what I get? A squared plus b squared equals c squared. If you had plugged in another number for c, if I plug in the 18 plus x, if I say 18 plus x squared, guess what? A squared plus B squared does not equal C squared. So just remember that, guys. There are multiple ways to solve these problems. If you just can't remember, you work out the math and it doesn't work, it's like, man, my answer doesn't match any of these things. Remember, there are ways to be able to figure this out using your calculator and the trick that I've taught you guys, especially on the calculator portion, of course. Okay, let's keep going. Given the expression 2n squared minus n minus 3, what is the coefficient of the n term? Coefficient just means the number that's multiplied or attached to a variable. So 4x squared, the coefficient is just that number in front. Okay, so what's the number in front of the n term? Okay, there's nothing there. Okay, so it's understood to be a 1. So the coefficient is -1. Okay, there's a negative there, so that makes that coefficient -1. It's not 1. Okay. Which expression is equivalent to 121x to the 4th minus 64y to the 6th? There's no equal sign here, guys. I'm not solving anything. I'm not setting this equal to 0. There's no quadratic formula. There's none of that stuff. I am factoring here. I'm not solving anything. Okay, so if you guys remember, this was number 2 on my chart on the wall over there, on the wall in green. This says special cases / difference of squares. So if you guys remember, with a difference of squares, I have something like x squared minus 16. And I know that's a difference of squares because the x squared is a perfect square, the 16 is a perfect square, and I have a minus in the middle. Difference, minus, a difference of perfect squares. And so the way I taught you to solve that was you just take the square root of the first and the second term. X squared root of x squared is x, square root of 16 is 4, and one of your factors is positive and one of your factors is negative. If I were to FOIL this back out, first, outside, inside, last, minus 16, guess what happens? Oh, sorry. Guess what happens to the two middle terms? -4 and 4x cancel out, and I'm right back to where I started. Okay. So basically, you can see here that's what they got for the answers. One of your factors is positive, one of your factors is negative. So basically, what you have to do here is you have to take the square root of both of these. Okay. Square root of 121 is 11. The square root of x to the 4th is x squared. Square root of 64 is 8. And the square root of y to the 6th is y to the 3rd. I'm just dividing each of these exponents by 2, just like we did in the radicals unit. And then remember, one of your factors is positive, and one of your factors is negative. So which one of those is correct? That is going to be letter D. Can I check this, boys and girls? You betcha. Let's check it, check it, check it, check it. All right, let's type in the original problem, 121. And as you check these, guys, you'll get faster at it. 121x raised to the 4th. Put my cursor back down. Let me show you what I just did there. 121x raised to the 4th. If you have my calculator, look where the cursor is. It's up in the superscript. You can't do that. If I start pressing buttons, notice I'm still up in the superscript. I don't want that. So I've got to press x to the 4th. I've got to press the over button and drop back down. Okay. So 121x to the 4th minus 64 alpha y raised to the 6th. And I get a number. Fine, whatever. Don't care what that number is. It's got 10 zeros behind it. Whatever, that's fine. Let's type in what we think that simplifies to. Parentheses 11x squared plus 8 alpha y raised to the 3rd. Drop your cursor back down. Close the parentheses. Open another set of parentheses. 11x squared minus alpha y raised to the 3rd. Drop my cursor back down. Close the parentheses. Oh, did I type something in wrong? Let me go back and type that in again. Okay, so type in 11x squared plus 8 alpha y raised to the 3rd. Drop my cursor down, close the parentheses. 11x squared minus 8 alpha y raised to the 3rd. Drop my cursor down, and there we go. Okay, so now I guess I punched something in wrong back up here. So now you can see that the numbers match. Okay, so again, that's a great way to check your answer. And I'm kind of glad I actually punched something in wrong, so you can see. Wait a minute, if these guys don't match, you did something wrong. Now I made a mistake. I just typed something in the calculator. But if these guys don't match, that means you did your math incorrectly. Okay, so something's wrong. You can go back and figure out where you made your mistake. Okay, 32. Given the expression 6a squared plus 7a minus 3, which of the following is a factor of the expression? Okay, and so this is a way, guys, that they have a way to ask these questions in a way that forces you to know how to factor these things. And a lot of you guys say, well, when I saw quadratics, Mr. Maniz, I just want to use the quadratic formula every single time. Okay, that works. You can do that, even though factoring and square root methods, some of these other methods are just 10 times faster and easier. Quadratic formula will work every time. But we can't use the quadratic formula on this one because, guys, there's no equal sign. Quadratic equation and completing the square, those are for solving for the roots, the zeros, the x-intercepts, the solutions. We're not solving anything. There's no equal sign here, okay? We are just simply simplifying this. We're factoring this. If I factor 6, I'm breaking that down into 2 times 3. I didn't solve anything. I'm just saying 6 factors is 2 times 3. All right? It's the same thing here. So we have a couple options, factoring when a is 1, factoring when a is not 1. Well, a is obviously not 1 in this case, so I'm going to come down here, give myself some room. This is where we have to use the grouping method. Y'all remember that? The curtain? All right, so the first thing you got to do is multiply a times c. Okay, 6 times negative 3 gives me negative 18. Guys, that is a temporary number. That number will not show up anywhere else in the rest of the problem. I'm just using that number to figure out what are the factors of this temporary number that add to the b term. Okay, just like if a is 1, we say what are the factors of c that add to b? Well, in this case, what are the factors of a times c that add to b? Okay, the first two numbers that pop in your head for 18, maybe 6 and 3, that won't get me to a 7. What else? 9 and 2, okay, there we go. 9 and 2 will somehow get me to a 7. It's got to multiply to give me a negative number. So one's negative, one's positive. And the sign of the middle term tells you the sign of the larger one. So since this is positive, the 9 will have to be positive. So the factors are positive 9 and negative 2. Okay, that multiplies to give you negative 18. That adds to give you 7. So what I'm going to do now is I'm going to split this. And here we're going to split this middle term so I'll have 4 terms so I can draw my curtain in factor by grouping. Now guys, it doesn't matter where you put the 9 or the negative 2. I can put the 9 with a 6 or I can put the 2 with a 6. Alright, we'll use the 2, that's fine. So I'm going to bring down my 6a squared. I'll put the negative 2a with the 6. And then I'll put the 9a with the 3. So look what I did. Let me just stop for a minute. This is the whole gist of the curtain thing. All I did, guys, was I took $7 and I broke that down into negative $2 plus $9. 9 minus 2 is 7. So I haven't changed anything. I haven't changed the equation. I just broken the one term down into 2 separate terms. But now watch what I get to do. Now I get to, let's do this in green. Now I get to draw my curtain, and now I get to group. So don't worry about any of this stuff on the right. Let's just look at the left. What is the GCF? What is the greatest common factor that I can pull out of both of those? 2 divides evenly into both of those. And then what else divides into each of those? They both have an A, so I can pull out an A from both of them. Okay. To figure out what's left over, I have to take each of these terms and divide it by the GCF that I pulled out. 6a squared over 2a is 3a. And then negative 2a over 2a is just minus 1. Okay. Now we don't look at the left, we look at the right. I've got 9a minus 3. What is the GCF I can pull out? I can pull out a 3. I can't pull out an a because a 3 doesn't have an a. Now guys, before I even write anything down, what has to be true about what's in this parentheses? It's got to match that parentheses. So me personally, Mr. Maniz, I just go ahead and write down the matching expression here. But I always go back and check to make sure I didn't make a mistake. 3 times 3a, yeah, that's 9a. 3 times negative 1, yeah, that's negative 3. And so these guys match. Do not pass go. Do not collect $200 unless those two binomials match each other. Okay, so what are my actual factors? Okay, the factors are, this is one of them. Whatever you put in parentheses, that's one of your factors, 3a minus 1. The other factor is the stuff left over on the outside. That's going to be 2a plus 3. Okay, if you were to FOIL this back out, guess what? You'd get right back to where you started. So what's the correct answer? The correct answer is this one, the 3a minus 1. Okay. So we don't really have a way to check this on our calculator, guys, because they're kind of sneaky. They're only asking you for one of the factors. Now, if your answer choices had both factors, if one of your answer choices was this, 3a minus 1 times 2a plus 3, if they gave you both factors, then shoot, yeah, I can just type this into my calculator. I'll just type in 6 alpha a squared plus 7 alpha A minus 3, get a number, and then type in 3 alpha A minus 1, and then times the 2A. Actually, I guess I should type those in together. 3 alpha A minus 1 times 2 alpha A plus 3, and they match. Okay, but we can't do that here because our answers only have one of the factors. Okay, so in this case, you kind of have to know how to do it. All right. So let's keep going. Flip on over to the back. What is the vertex of the graph x squared plus 10x minus 9? Okay, there are two ways to do this. There's an easy way and there's a hard way. Hopefully this will be a calculator problem. You can use your calculator on this. Alright, so I'm going to type this in. I'm going to go y equals, type in my quadratic, x squared plus 10x minus 9. Okay, let's go ahead and graph this. Whoa, what is that? I can't even see it. Okay, well, first of all, if your screen doesn't look like mine, you can press the zoom button, zoom 6. That gets you back to your standard window. But even my standard window, guys, I can't see this. I need to be able to zoom in on the vertex. So there's a little trick that I taught you. Press zoom, and I want you to scroll all the way down to 0. See that guy right there, zoom fit? That is a beautiful thing. Press enter, zoom fit, and check this out. My goodness, how cool is that? It zooms right in on the vertex. Do you guys remember our little friend Mr. Spidey? We're going to use Mr. Spidey to find the vertex. Now, we're not trying to find the roots, guys. We're not trying to solve for the zeros. I'm not trying to solve this quadratic. I just want to know what is the vertex. What are the coordinates of the vertex? So we're going to use Mr. Spidey to find that spot. And to find Mr. Spidey, we're going to press second calc. Second calc. Okay. Now which of these am I going to select? I don't want the zeros. I don't want the roots, solutions. I need a minimum or a maximum. So if I go back to my graph, what are we looking at? Is that a min or a max? That's a min. It comes down to a minimum value and then it goes back up. So second calc, go ahead and select minimum. And there's Mr. Spidey. He's on the spider web. There he is, Mr. Spidey. Okay, my calculator says, Mr. Manise, I need you to move Mr. Spidey to the left. Give me a left bound, please. I say, okay, no problem. Hold the over button. I'm going to scroll, move Mr. Spidey. In this case, it's kind of hard to see Mr. Spidey, but you'll be able to see him here in a minute. There he is. He's down there behind the numbers. He's there. There he is. There he is. I just need to move Mr. Spidey, guys, to the left of the vertex. That's plenty good. That's good. Press enter. My calculator says, Mr. Manise, I need you to move Mr. Spidey to the right, please. Okay. I'm going to move Mr. Spidey all the way to the right. Anywhere to the right of the vertex, fine. It's fine, guys. Anywhere to the right. I'll go way up here just so you guys can confirm he's definitely to the right of the vertex. Press enter. My calculator says, Mr. Manise, are you ready for me to guess the vertex? Yes, Mr. Calculator, I want you to guess. Press enter a third time, and voila, there is your vertex. -5, -34. So there's your answer. -5, -34. Now, if you don't have a calculator, guys, if you're one of those students who have always borrowed a calculator from the teacher, you haven't been able to practice at home, maybe you're not going to be able to have a graphing calculator on the test, which makes me very sad. There is a manual way to do this. And to do this manually, we have a little phrase, a little term here called -b over 2a. Okay, so you need to instill that in your brain if you're not going to have a calculator on the test. That is going to tell you the x coordinate of the vertex. Okay, so what is my b and what is my a? Well, we treat this just like a normal ax squared plus bx plus c. That's a normal three-term trinomial, quadratic trinomial in standard form. So my b is going to be this guy right here. There's my a, there's my b, and there's my c. All right, so I've got -10. Let me do this up here. -10 over 2 times a. What is my a? There's nothing there, so it's just a 1. -10 over 2 gives me -5. That is the x coordinate of my vertex. Notice that's what that is, the -5. Now, to find the y coordinate, because notice one of the other answers is also -5. It's got to be one of these two. The way to find the other coordinate is you're going to take this guy and you're going to plug it back in for x there and plug it back in for x there. Okay, everywhere you see an x. So I've got -5 squared plus 10 times -5 minus 9. -5 squared, that's 25. 10 times -5 minus 50 minus 9. And guess what? that comes out to be negative 34. And that's how you find the y coordinate of the vertex manually using this guy right here, negative b over 2a. If you got your calculator, just use Mr. Spidey. Okay. All right, number 34. This is a tough one. Consider the parabola in standard form y equals negative 2x squared plus 12x minus 5. This is to be rewritten in the vertex form by, you betcha, our best friend, completing the square. Man, we ought to be good at this by now. We've completed the square so many times with parabolas, solving quadratics, and circles. We ought to really be good at this by now. In completing the square, what should that guy be in the following equation so it's still the same parabola? So basically what they're asking us to do is to complete the square and figure out what this number is. Okay, so to complete the square, all right, so I've got y equals, now when I complete the square, guys, this is what makes this problem hard. When I complete the square, I cannot do that unless this a value is 1. It is not 1. They're mean to us, okay? So they didn't let it be 1. I've got to factor out that term, whatever it is. If this is a 4, 3, monkey, smiley face, whatever, I've got to factor that out, okay? Hold on just a second. Somebody's knocking at my door. Okay, that was fairly scary. I just had a teacher knock on my door and ask me if I smell fire. So, yeah, so if this video just kind of shuts down and you guys don't hear from me again, then it's been nice knowing you. Okay, just kidding. All right, so let's keep going. All right, so I'm going to factor out a negative 2. All right, and that's going to leave me with, and also, guys, the way I taught you to do this is to put brackets around those two terms, and this is exactly why I teach you to do that, because I want your brain to just focus on those first two terms. I'm completing the square on those two terms. I'm factoring out a negative 2 just from those two terms, okay? So that's going to leave me with x squared. I'm just going up here and dividing each of these terms by negative 2. That's going to leave me with x squared. 12x divided by negative 2 is minus 6x. And now I'm ready to complete the squares. There's my plus blank. And then this guy doesn't get to play. Okay, so he stays outside. That's why I put the brackets there. And then I'm going to have another blank. I don't know if that's going to be positive or negative because both of the blanks are on the right-hand side of my seesaw, the right-hand side of the equal sign. Hopefully you guys know this by now. Completing the squares, half of b squared. Half of b squared. So half of negative 6 is negative 3, and negative 3 squared is 9. Okay, so I'm going to stick a 9 in that blank. Okay, and everybody says, oh, well, I'm going to put a negative 9 in that blank to offset. Yes, you're right, except for the fact that we factored out a negative 2. The whole point of putting a negative 9 here is because I dropped 9 bricks on the seesaw, so I got to take off 9 bricks. These guys have to offset each other. But I did not put 9 bricks on the seesaw. I put negative 2 times 9 bricks on the seesaw. Okay, so negative 2 times 9 is negative 18. Okay, so I put negative 18 bricks on the seesaw, which means I need to offset that with a positive 18. Okay, positive 18. All right, so if you're not sure why that is, if you were to refoil this back out, watch what happens if you had put in a negative 9 there. If I foil this back out, negative 2 times x squared is negative 2x. Negative 2 times negative 6x is plus 12x. Negative 2 times 9 is minus 18. And then I have the minus 5. And then if you put a negative 9 there, okay, if you put a negative 9 there, watch what happens. I have negative 2x squared plus 12x minus 18 minus 5 minus 9. That's negative 20. That's minus 22. So that's like negative 2x squared plus 12x minus 22. Notice that's not where we started. Okay, that's not the same thing. But if you put the 18 in there, if you offset it with an 18, so then this number becomes 18. Now watch what happens. The negative 18 and the 18 cancel, and guess what? Now I am right back to where I started. Okay, so the final answer for this problem is 18. Okay, can I check this? Why, yes, you can. You sure can. All day long. Let's type. Don't type in the y equals. Let's just type in this expression and get a number. Negative 2x squared plus 12x minus 5. Get a number. Okay, whatever. Don't care what that number is. Don't care what that number is. Okay. And then I'm going to type in this expression down here with the new a value. I think it's going to be 18. Okay, so let's type that in. Make sure I can see this. -2 parentheses x squared minus 6x plus 9, close the parentheses, and we're saying the answer is 18, so plus 18 minus 5, and guess what? I get the same thing. By the way, that's the weirdest decimal I've ever seen in my life. -115 with 4 zeros in front. Okay. But whatever, they match. Confetti falls from the sky, and I move along. Now give Mr. Meese a high five after the EOC is over because you just aced it. Okay, number 35. The expression -x squared plus 70x minus 600 represents a company's profit after selling x items. For which numbers of items sold is the company's profit equal to 0? So guess what I'm going to set this equal to, guys? They literally tell me to set it equal to 0. -x squared plus 70x minus 600 equals 0. So now I do need to solve this equation. I've got an equal sign here. I need to solve it and figure out what my two solutions are. My two solutions will be these items. So now, for some of you guys, if you want to use quadratic formula, go ahead, knock yourself out. I'm not going to try to stop you. However, we can factor this, but if I do factor this, I can only factor when a equals 1. Well, a doesn't equal 1. A equals -1. So before I try to factor this, I need to factor out this negative, which basically just means I'm going to flip all the signs. I'm going to factor out a -1. That's going to leave me with x squared, change that sign, -70x, change that sign, plus 600 equals 0. And the -1 goes away because if I divide both sides by -1, those just cancel, and 0 over anything is just 0. So this is what I'm trying to factor. X squared minus 70x plus 600 equals 0. So now I've got to ask myself, what are the factors of 600 that add to -70? Okay, so when you ask me what are the first two numbers that pop in your head that multiply to give you 600, I'm going to say 60 and 10, right? That's the first thing that pops in my head. I'm going to say 106, or I'm going to say 60 and 10. Okay, so were either of those combinations get me to a 70? And the answer is yes. They have to multiply to give me 600, but they have to add to give me -70. So my factors, they both have to be negative since they have to be add to -70. So my factors are -60 and -10. Those two numbers will multiply to give you 600. These two numbers will add to give me -70. Okay, so factors, these are my two factors. So it factors as x minus 60 and x minus 10 equals 0 though. So what do I have to do with these signs? I have to flippy flip. So my two answers are 60 and 10. Okay. See, now if you wanted to solve that using quadratic formula, I guess I'll go ahead and do that just for y'all's sake, for those students who really are just bound and determined to use quadratic formula every time if it's possible. Alright, so the way I taught you to do quadratic formula is to come out here to the side. Please do this if you use quadratic formula. The reason I don't encourage quadratic formula all the time is because there's so many chances to make a mistake with negatives, double negatives and all that stuff. So that's why I say come out here and write down your A and your B and your C. So here's the first place you can make a mistake, is a lot of students will just write down 1, but no, my A is -1. My B, and I'm looking at the original problem here. My B is 70, and my C is -600. Okay, so we sing the song. Quadratic formula is -b plus or minus square root of b squared minus 4ac all over 2a. You will have that at your disposal on the test. So now it's just plug and chug. I'm going to plug in b. So it's going to be, I need some more room. Alright, so it's going to be -70 plus or minus the square root of b squared, so 70 squared, minus 4 times a, which is -1, times c, which is -600, all over 2 times a, 2 times -1. Okay, so let's come over here. Let's simplify a little bit. I've got -70 plus or minus. Now at this point, guys, I would do this piece in your calculator. Okay, let's just type that part in. Don't try to do all this at once. Let's just type in 70 squared minus 4 times -1 times -600. Okay, that's going to be the square root of 2500. Okay, all over -2. Okay, so what is the square root of 2500? That's 50. Okay, so the square root of 2500, this just simplifies to 50. So basically I'm going to have to write this down here. So basically we have negative 70 plus or minus 50 all divided by negative 2. So one of my answers is going to be negative 70 plus 50 divided by negative 2. That's negative 20 over negative 2. There's your negative 10. My other answer is going to be negative 70 minus 50 divided by negative 2. That's negative 120 over negative 2, and that's positive. That's going to be, sorry, this is positive. Negative 20 over negative 2 is a positive 10. This is negative 120 over negative 2, and that's a positive 60. So notice we still get the 10 and the 60. But man, I don't know, that just seems like a whole lot of work to me, as opposed to just saying what are the factors of 600 that add to negative 70. But you can get the same answer either way, whatever you choose. Okay, 36. A garden measuring 8 by 12 feet will have a walkway around it. The walkway has a uniform width, and the area, there's a trigger word, area covered by the garden and the walkway is 192 square feet. Okay, so what is the width of the walkway? Okay, so we're increasing by x over here, we're increasing by x over here, increasing by x over here, increasing by x over here. Alright, so the garden is 8 by 12. Okay, but if I'm increasing this, if this length is 12, okay, then this new length from here to here is going to be what? It's going to be this x and another x, that's going to be 2x plus the original 12. So let me stop there and make sure everybody's okay with what I just did. This length is 12. This new length is, I've got an x over here and a new x over here. So I'm going to add the x and the x. So this new length is going to be 2x plus 12. If I flip it, and if I look at the width here, I've got an x over here and I've got an x over here. So this new width is going to be, again, 2x plus 8. Okay. So here's my new length. Here's my new width. Okay. They're telling me that the walkway, when they get done, is going to be 192 square feet. And they want to know what is the width. So to find the area, I need to multiply the length times the width. Okay, so if I do that, I'm going to FOIL. I'm going to multiply this new length times this new width. That's going to be 2x plus 12 times 2x plus 8. Okay, when I FOIL first, that's 4x squared. Outside, 2x times 8, that's 16x. Okay, inside I have 12 times 2x is plus 24x, and then last 12 times 8 is 96. Okay, so let's combine our like terms. 4x squared, 16 apples plus 24 apples is 40 apples, plus the 96. But this area, guys, this is the area, length times width. That area is now going to be equal to 192 square feet. So I've got to set this equal to 192. And now I have a quadratic that I need to solve. The first thing I'm going to do is I'm going to get this guy set equal to 0. You want all of your quadratics set equal to 0. It's set for completing the square when you move the constant to the other side. Okay, but for the most part, we want it set equal to 0. So I'm going to move this guy to the other side. Those cancel. So I have 4x squared plus 40x. 96 minus 192 is negative 96. I'm going to set that equal to 0. And now I'm going to solve. If you want to use quadratic formula, knock yourself out. But I want you guys, for those of you who have me as a teacher, I want you to visualize looking at that chart on the wall over there. Okay, what was the first thing on the wall? GCF. Is there a GCF that I can pull out? Absolutely. All three of those terms are divisible by 4. So why don't we factor out of 4? I'm going to take out a 4. That's going to leave me with x squared. 40 divided by 4 is plus 10x. Negative 96 divided by 4 is negative 24. And that equals 0. And this 4 goes away, guys. When you factor out that GCF, it just disappears. When I divide both sides of the equation by 4, like we did earlier, that just goes away. So basically what I'm doing is I'm factoring x squared plus 10x minus 24. Man, that is so much easier. What are the factors of 24 that add 10? Okay, what are the first two numbers that pop in your head when you see 24? 6 and 4, right? Will that get me to a 10? Well, one of the numbers has to be positive and one of the numbers has to be negative. So if it's negative 6 and 4, that doesn't get me there. negative 4 and 6, that still doesn't get me there. So the 6 and 4 don't work. What else do you think about with 24? 8 and 3, right? 8 and 3, that can't get me to a 10. What else? 12 and 2, right? That will also get me to a 10. This is negative, so one of them has to be positive, one has to be negative. So since the sign of the middle term is positive, that means the bigger one has to be positive. So this is going to factor as x plus 12 and x minus 2. What do I do with the signs? Flippy flip. So x is going to be negative 12 and positive 2. But we're talking about an actual width of the walkway. Can I have a negative width? No, absolutely not. So the final answer is 2 feet. Okay, what are the solutions to this equation? Okay, so 2x squared minus 2x equals 11. Again, I want my quadratic set equal to 0, so I got 2x squared minus 2x, move the 12 to the other side, minus 12 equals 0. So once again, can I pull out a GCF? You bet. Factor out of 2, that's going to leave me with x squared minus 1x, or just minus x, and then plus 6. Or excuse me, that's minus 6, sorry, minus 6. Okay, so once again, the 2 just disappears, so we got x squared minus x minus 6 equals 0. All right, what are the factors of negative 6 that add to negative 1? That's going to be a negative 3 and a positive 2. So it factors as x minus 3, x plus 2. What do I do with the signs? I flippy flip. So x equals 3 and x equals negative 2. Okay, can I go back and check this? Absolutely. You can go back and plug in a 3 for x. That's what we can do. So this is a little different, guys. You can't use the trick of just typing in the variables and getting a number and see if they match, because now we have an equal sign. Okay, that you can use that trick when you simplify. So now the trick that I'm going to use is I just want to plug this in and see if the left side equals the right side. So if I plug in a 3 here for x, I've got 2 times 3 squared, and then I've got minus 2 times 3. Does that equal 12? There you go. If I plug in a negative 2, I've got 2. Now don't miss this, guys. Don't miss this. I've got to put the negative 2 in parentheses. Negative 2 squared minus 2 times negative 2. And guess what? That still equals 12. So that's how you can check. One more thing. If this is on the calculator portion, guys, if it's on the calculator, you can graph this. Oh my goodness. This is another way to do it. Go to y equals, type in 2x squared minus 2x minus 12. Let's graph it. Okay, I've got a weird window, right? Because I did that zoom fit. I don't want to do that. I want to go zoom. Let's go back to zoom standard, zoom 6. All right, guess what? Guess where my graph crosses the x-axis, guys? Take a guess. Looky look. It crosses at negative 2 and it crosses at 1, 2, 3. Okay, so wherever your parabola crosses the x-axis, those are the solutions, the roots, the zeros, the x-intercepts to your quadratic. Now I imagine that they might ask you how to solve one of these quadratics on the non-calculator part, so yes, you do need to be able to use factoring or quadratic formula, but shoot, if this is on the calculator part, just graph it and see where it crosses the x-axis. You're done. Okay, let's keep going. One more page down. Okay, 38. What are the solutions to this system of equations? Okay, I can show you the mathematical algebra way to do this. I did teach this to you guys, and I'm going to teach you the surefire shortcut way. So let's do it the long way first. Okay, so to solve a system, I'm going to use the substitution method because one of my variables is already isolated. I already have y equals something, y by itself. So I'm simply going to take that expression and I'm going to substitute it right there for y. So instead of y in the top equation, instead of being y, I'm just going to substitute 12x minus 6, and that's going to be equal to the rest of the stuff in the top equation. 5x squared plus 7x minus 6. All right. Guess what? That's a quadratic that we need to solve. Let's get everything set to 0, so let's move these to the other side. Well, that cancels. So I'm left with 5x squared. 7x minus 12x is minus, that's the squared, is minus 5x. Negative 6 plus 6 cancels. Okay. Now, guys, you don't need quadratic formula for this. This is GCF all day long. What can I pull out from both terms? They both have a 5, they both have an x. So I'm going to factor out a 5x. That's going to leave me with x minus 1. Okay. If I set each of these equal to 0, 5x equals 0, divide both sides by 5. I literally get x is equal to 0. And if I set x minus 1 equal to 0, I just flippy flip, I get x is equal to 1. Okay. Alright, so I've got x is equal to 0 and I've got x is equal to 1. Okay, so which one of these over here has the 0 and the 1? Okay, so if I've got two x's here, let me take a step back. If I have my two x's, before I do that, I need to go back and plug back in to figure out what my y's are. Okay, so I'm going to take each of these one at a time. I'm going to plug in 0 for x. So one of my y's is going to be 12 times 0 minus 6. So one of my y's, I'll do this over here. One of my y's is just going to be negative 6. Okay, so when x is 0, y is negative 6. So one of my points is 0, negative 6. And then I'm going to take the 1, and I'm also going to plug that in for y. So my other y is going to be y equals 12 times 1 minus the 6. That's just 12 minus 6, which is 6. So my other point is going to be 1, 6. And those are my two answers. 1, 6 and 0, negative 6. So the correct answer is C. 0, negative 6, and 1, 6. Okay, now that's kind of long-winded. Yep. There's an easier way, guys. I hope this is on the calculator part. So let me teach you, or I've already taught this to you. Let me show you again, refresh your memory. You're simply going to go to y equals and type in both of your equations. I've got one quadratic, 5x squared plus 7x minus 6, and then I have a line. This is coordinate algebra stuff. That's just y equals mx plus b. 12x minus 6. I'm going to graph those guys. And again, I hope they don't give something like this to you. This is really hard to see. The line is kind of coming down here, okay, but it's intersecting the parabola at two spots. So we can use Mr. Spidey to find the two spots where the two graphs intersect. Okay, those are the two solutions. So to do that, I'm going to use Mr. Spidey, go second calc. Okay, so now what do you think I'm going to select? I want the intersection. I want the intersection of the parabola and the line. Okay, so I'm going to select 5, so press 5. So here, my calculator is saying, okay, Mr. Manice, I don't know which point you want me to find. One of the intersections is down here, one of the intersections is up here. So it's saying, where's the first curve, Mr. Manice? I'm going to say somewhere down here. Notice right now, Mr. Spidey's he's on the parabola. I just need to move Mr. Spidey somewhere close to that intersection. Somewhere right in there is fine. Right there, press first curve. Second curve, stay right there, press yes, press enter a third time, and there is our first intersection. Okay, you might be asking, what in the world is that number? 3.2 e to the negative 15. Guys, that is 0.15 zeros. 0.0000015 zeros. That's basically 0. Don't ask me why. I don't know why Texas, it's like a flaw in their software. I don't know why it's not just 0. But it's 0, negative 6, which is what we got up here. In fact, you could see when I did second calc with the intersection, if I do it right there, it actually does show 0, negative 6. Okay. To find the other intersection, I'm going to go second calc again, go down to intersection. Now I want the second intersection, which is somewhere up here. Okay. Wow. I've been sitting still so long, the motion sensor in my room didn't sense that I was moving, so it shut the lights off for a second. That's funny. All right, so the other intersection is up here. So, yep, first curve. Yes, second curve. Yes, I want you to guess. And there we go. There's the other intersection, 1, 6. Okay. Hopefully on the EOC, if you see that kind of problem, it'll be a lot more apparent where the 2 points are. And just move Mr. Spidey 1, 2, 3. Mr. Spidey, enter 1, 2, 3, and it'll spit out the coordinates of the intersection. Or you can do it manually, like I showed you. Okay, number 39, use the table to answer the question, what is the average rate of change over the interval from -2 to 0? Okay, that's probably going to be on there, guys, because it's on the formula sheet. Average rate of change, the change in the y value divided by the change in the x value for two distinct points on the graph. Okay, so the way you do this is kind of like slope, really. Average rate of change, if you guys want to write this in your packet, average rate of change just means slope. Okay, so basically, if you guys remember from last year, the slope formula is y2 minus y1 over x2 minus x1. It's just the change in y, the change in my y values, and f of x is the same thing as y. It's the change in my y values divided by the change in my x values. Okay, but they only want it over the interval from -2 to 0. So they only care about from here, from -2 to here. That's all they care about. Okay, so if you want to plug it into your slope formula, if you want to just think rise over run, you could do that. In fact, if you guys wanted to plot this on your graph paper on the EOC, you could plot these 2 points on your graph paper and you could do rise over run. Okay, the average rate of change. You could just count up and count over, and that would give you a rate of change. Okay, but if you want to do it from the table, we're going to need to plug these points into the formula. This will be like my x1, this would be like my x2, this would be y1, this would be y2. So I'm going to take this second y minus the first y, so I've got 5 minus 15, the change in my y's, over the change in my x is 0 minus a -2. Okay, don't miss that, guys. That is a double negative. 5 minus 15 is -10. 0 minus a -2, that's 0 plus 2, which is a 2. -10 over 2 is a -5. So my average rate of change, or my slope, is a -5. Okay. Next one. What is the end behavior of a excuse me? End behavior of a graph that a quadratic is f of x equals -0.25 x squared minus 2x plus 1. If you guys remember end behaviors, guys, end behaviors are super easy. There's a right side up parabola. Where are these two end behaviors going? Where are these two y's going? They're both headed towards positive infinity and positive infinity. If it's an upside down parabola, if it looks something like this, then both of my y's are headed towards negative infinity or negative infinity. It's either one of the two, both up or both down. That's it. So as x increases, as we go this way, what happens to the y values? All right, so in this case, how do we know which way the graph opens, up or down? Okay, well, there's a negative there, so that means it's a reflection. So that means we're in this land. Or, if you can't remember that, just graph it on your calculator. Go y equals, clear all that stuff out there. Clear. There we go. All right, so let's plug it in. Let's plug in what we got. I'm trying to make sure you guys can always see this on the camera. -0.25 x squared minus 2x plus 1. And let's graph it. Well, guess what? The graph opens upside down. Okay, so both of my end behaviors are both headed towards negative infinity, down and down. Okay, so which answer choices can I get rid of? It can't be A or C because that's going up and down. That's going, oh, sorry. I can X out A and D. That's up and then down, and then that's down and then up. Okay, they either both have to be up or they both have to be down. All right, so in this case, they're both headed towards negative infinity, so they both have to be heading down. They both have to be decreasing as you get closer and closer to the end of the graph. How's the graph behaving? They are both decreasing. Okay. All right, let's keep going. Number 41. What explicit expression can be used to find the next term in the sequence? Okay, so the way that you would do something like this is I'm simply going to write down each of these terms. This is like term number 1, this is term number 2, this is term 3, term 4, term 5. Those are my nth terms. Okay, so I'm simply going to type in or plug in these numbers for n and see if they match these numbers up here. All right, so let's follow the pattern. If I plug in a 1, the nth term, the first term, 2 times 1, is that 2? Yeah. What about if I plug in the second term? 2 times 2, is that 8? Ooh, no, it can't be that one. Let's plug in term number 1, the first term. 2 times 1 is 2, plus 6. Does that equal 2? No. Let's plug this one in. The first term. 1 squared is 1. 2 times 1 is 2. Okay, that works. Let's plug in the second term for n. 2 times 2 is 4. 4 times 2 is 8. That works. Let's plug in the third term. 3 squared is 9. 2 times 9 is 18. That works. 4 squared is 16 times 2 is 32. There you go. That's the pattern. So if I wanted to know what is the 100th term, I would stick in 100 for n, I would square that times 2, and that would give me the 100th term, the nth term. 42, given that line M is parallel to line L, find the value that makes the diagram true. Okay, here's where you can use Mr. Manise's trick, guys. With parallel lines, remember, all the big ones are the same, all the little ones are the same. Okay? If I have two parallel lines cut by a transversal, that's little, that's little. They're going to be the same. When I say big and little, I mean acute and obtuse. All the angles that are less than 90, they're all going to be the same. All the angles that are obtuse greater than 90, they're all going to be the same. Here's a big obtuse angle. There's a big obtuse angle. They're going to be the same. So if these lines are parallel, this guy right there, is that big or little? That's little. That's an acute angle. This angle right here, is that big or little? That's little. They're acute angles. Okay. So if they're both little, they're going to be equal to each other. So I'm simply going to set these expressions equal to each other. 4x plus 10. Subtract x from both sides. 40 equals 3x plus 10. Let's subtract 10 from both sides. 3x equals 30. So x is equal to 10. Okay, there's your answer. If you don't remember that, guys, you could have remembered that this angle is inside, this angle is outside. If you think about the box, the window, they're both in the same position of the window. They're both in the bottom left of the window, so they're corresponding angles. So the other way to work this is, if you don't remember the trick, is just remember when lines are parallel, corresponding angles are congruent. Corresponding angles theorem. Okay, and you can check it. Let's plug back. Let's make sure we did our math correctly. 10 plus 40 is 50. 4 times 10 is yeah, x plus 40 is 50. 4 times 10 is 40, plus 10 is also 50. Yeah, so they check out. Okay, let's keep going. Actually, you know what, guys? I'll have to stop there. I just realized the bell's about to get me. I'm sorry, guys. I know this is going to be about a 3-hour video, but if you really want a good grade in geometry, you're going to have to work this hard. It is, for a lot of you guys, it's the hardest math class you'll ever take in geometry. So you got to put in the work, you got to put in the hours, and we'll get this done. Okay, so this is it for part 2 of the video. We'll see you on part 3.